students. Okay, this is going to be week 1. We'll just call this Q&A session. And this will be also announcement. Kind of making this up as I go along. I've never actually taught Organic 1 online. Most of my activities are designed for face-to-face in interaction. So, but that's okay. This is what we can do. Now, so I'm going to take this probably be about 20 minutes, and I'm going to try to capture some of the questions you all might have already asked, some of the issues I have seen in grading your POGL activities. So we'll deal with questions, and we will deal with the POGL activities, and the quizzes. So every week I'm going to do some kind of Q&A session. Maybe some weeks I do 2 Q&A sessions, and I'm going to create a Blackboard module, and it's just going to be the Q&A sessions, and this will be week 1. And instead of, we have about 27 students, and this way I'll try to address most people's concerns. Okay, so if we need to, we can do a Zoom, and I can try to do something like that. But I feel like I need to be able to write and draw things. So I would rather you all spend your time working the problems and listening to the videos and working the POGL activities and your online homework, rather than to put something else, some activity on you. So that's why I have not decided to do that. Because now, so the learning goals this week. 1, I want to congratulate you all. So I'm going to write that down. Congratulations. Okay? What you have done this week and accomplished is you've learned how to communicate with me. I think each one of us have communicated by email. Some people have called my phone in situations where they needed help. We've learned about the resources. We've learned what books, Blackboard. If you were able to submit a quiz, you were able to understand how to do sapling. You had to have a sapling account. And on the quiz, on the open response, you had to download that Blackboard file. Okay? And you were able to troubleshoot if you had issues. We've also learned how to submit files. A lot of people have had to get the mini scanner app. Okay, it's a free app. And what I'm learning as I'm trying to give you feedback is when I write on these files and save these files, it even adds more, megabytes to the file, and they get really large. So make sure that you're just submitting your additional questions, and make sure you're collating that into a single file, and it's got to be a PDF file. And if it's too big, then it's going to get even bigger when I write on it and give you feedback. So at that situation, maybe that would be a good time to divide it up into 2 separate files if your file is too large. Okay, if you submit it and we find that it's too large, I can ask you to resubmit. So let's lose the stress. Okay, let's fix these technology problems. I will be patient with you. You be tenacious and persistent and resilient, and if we can get these qualities in place, we can lose that stress for the technology. Now what you'll notice is the same expectations are there every week. So congratulations. People have also told me a little bit about who they are, where they've taken courses before in previous semesters, their ambitions of where they want to go. For each person that was able to successfully submit assignments and meet this week's technology goals and give me information about themselves, I'm going to, once I get off of here and post this, I'm going to just add an extra 5 points to their participation and POGL's participation, folks. Okay, so you got so I'm just going to go through there and give everybody an extra 5 points on whatever you see right now. Okay, and then like I said, maybe quiz 1 we end up replacing with one of your better quiz grades. okay? We don't have time to take another quiz. You all have plenty of work to do. I think you all see that. And I'm pushing hard because I really don't want you all to get behind. We do have to cover 9 chapters, and normally this is a 16-week course, okay? And we're doing it in 6 weeks. But the good news is you don't have other classes. This is your only class. Some people have asked me, how do I best go about this? Or maybe I'm going about it incorrectly. Okay, you will need to be able to work problems. You will see what the quizzes ask you. You will see your exams are going to ask you problems, okay? So that's why I like the additional problems, okay, and your POGL. So if you want to, you can look at the POGL exercise that you turned in. Look at your open responses from your quiz. You're going to see that the expectations are the same, okay? So that is the first thing. Can you look through the POGL exercises? I was looking through POGL exercises while I watch the lecture video, because that's what we'll be doing in face-to-face. Okay? If you need to, and you have questions, and you get those POGL assignments turned in early, and I'll try to give you feedback early. You don't want to be spending the assessment days, and I say assessment days are quiz days and exam days learning the material, okay? You want to take this time. Today's Friday. You got Saturday and Sunday. Unfortunately, you probably have to work every single weekend. You know, probably I would put in at least 4 hours every single weekend on this material. Okay, you also, another ones is good, the problems that I gave you from the weight book. Okay, I would download those or get a piece of paper, draw those problems, work those problems, and then check out the video. Okay, so I would work backwards, you know, where some people take notes and then they go back. Work the problem, see what you know and you don't know. Learn your functional groups. Some people like to do, my best students in the past have kind of functional group app. I forgot what it's called. I think they spent a couple dollars on it. And they just looked at it every day and they would practice learning the functional groups. Functional groups, there is, I think, a lecture 3 is on functional groups, or lecture 2. But it talks about ketones. So that way you would recognize, oh, this is a ketone with the lone pairs, and you would see that that's a carbon double bonded oxygen, okay? So it'll make drawing these structures easier. The key is being able to draw good Lewis structures, and you'll see all of my examples are pretty much line drawings. So hopefully you're learning how to do that. Okay, so last night I spent until about midnight grading, giving feedback for your POGL activities. And this is what I found, okay? First, what are the topics hopefully you have learned this previous week, okay? Hopefully you've learned about drawing compounds, how to draw structures, and to classify them. Classify them as either same or structural, isomers, or different. Okay, so those are our 3 ways. So I'm going to try to do an example for each one of these from our POGL exercises. Hopefully you have learned about how to draw resonance structures. Hopefully you know how to put in the lone pairs when elements need formal charges, and how to draw the electron flow arrows to move the electrons along maybe some sp2 atoms. And those are your resonance structures. Resonance structures are hard, folks. There are people that graduate Organic 1. They get probably even Bs, probably a good strong B, and they still don't know how to draw resonance structures very well, okay? So it is a hard topic. Drawing compounds for the first time, it's hard topic, folks. You're doing stuff you have not done before. That's why I'm trying not to let you be so stressed out with files and types and expectations. Give yourself practice and just try to do it, and we just keep going at it. Okay, the other thing is how to write acid-base reactions. So, these are going to be important because you're going to see exam 2, and we have exam 2 on Thursday. And this will be about, I would say, I don't know, yeah, it'll be, well, it'll probably be, what's 3, 60, probably, yeah, I would say probably about 65, 75 points of your 200-point exam, okay? So these 3 topics that you've learned. Acid-base reactions. I would also download, it's in Learning Module Week 3, the reaction sheet. And I talk about this when I'm doing Chapter 4. But this is your first reaction. And I want to, and when you get done with Organic 2, you could look it up. I think it's about 180 reactions. So technically, you should probably have 180 reaction sheets by the time you get done with Organic 2. So I would recommend you download those reaction sheets. They're basically blank pieces of paper that you're going to fill in, and you keep it in a folder or a binder. So that way, when you're taking your final in Organic 2, you have those reaction sheets. And acid-base chemistry is your first reaction that you have learned in here. All right, so other things, other questions before I start an example on each one of these is hopefully you're getting into the rhythm, you're looking at the calendar. I do change the sapling homework dates. I can do that by my computer when I have 10 students or 5 students that can't meet a deadline goal. This can be for internet reasons. This can be because they didn't get sapling until that day. It is easier for me to extend out that deadline for the whole class than to go in for 5 or 10 people. Okay, for sometimes if there's just 1 or 2 people, I will go into sapling and I will extend that date. Some days I will move those other dates. So you do your sapling as you go along, okay? Because that is going to be one of your 100-point points. 150 points will be, so that's sapling. So you do it. It gives you immediate feedback. If you need extensions, I give you extensions. You don't have time to be lazy, so you're going to have to do something every day. 150 points for your quizzes. You also get 150 points for your POGL. Okay, there's no reason why you can't get good points here. And then you're going to have 600 points for exams. Okay, you get 3 exams in here, and I haven't really made anything like over chapters 1 through 9. They're each going to be over 3 chapters. Okay, now let's give an example of naming compounds. So I'm going to pick maybe one example in your additional problems, and or 2 examples, and go over that. Okay, so POGL additional questions. Let's look at page 13, and let's look at a line drawing here. Okay, so you just start here. This is CH3 because every carbon has 4 bonds, and then this one here is a CH. Okay, you don't see the H's. Remember the hydrogens are not shown. And you see how the OH branches off of the chain? So I'm going to put parentheses OH. Then this is CH2. This one is CH. And then it branches to CH3. And it comes off that chain. So I like to use parentheses for the branches. Now that is condensed formula. This is the line. Condensed formulas don't have lines in them, folks, okay? So if people drew covalent bonds anywhere, it was not correct. Okay. Molecular formula. How many carbons do you have? 1, 2, 3, 4, 5, 6. How many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And how many oxygens? 1. All right. Looking at this compound, and we compared it with this one here. This is CH3. This is a C, and then you have oxygen coming off of there. There's a CO. This is a CH2, CH, and then CH3. What's the molecular formula? 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1 oxygen. Do you see that these, you always compare the molecular formulas. Same or different? You ask yourself, are they same or different? Okay, same, yes, okay. Then connectivity, same or different, okay. If it's yes, it's the same compound. If it's no, then they're going to be structural isomers. Also, if they're same here, they could also be geometric isomers, and we talk about that in chapter 5. Okay, so we won't talk about that, but right now all you know is same. Okay, but we'll build on this concept. Here, are they different? So if they're different, then they're different compounds. So the best way is always to be able to convert that to molecular formulas and then compare the molecular formulas. When it asks you to explain, you say, you don't have to go through a half a page of everything that's different. You either, are they the same molecular formula? Are they different? You do this flow chart, okay? If yes, then what about the connectivity? So you're asking about molecular formula and connectivity, okay? And then, like I said, in chapter 5, we'll build on this again. So it's something you do need to learn. I made a mistake on 9. And that's another reason why I'm throwing in 5 points. Instead, I was going to do a 3-point. Instead, I decided to do a 5-point because I made some grading mistake on problem 9 on page 14. So when you did structures A and C, they are the same. They're the same molecular formula, and they're also the same connectivity, and they were the same. They're kind of flipped backwards, and hey, I make mistakes too. So I apologize for that, but that's number 9. Okay, so I think that takes care of drawing compounds in POGIL activity 1. Let's go to POGIL activity 2. Okay, in this one we're doing resonance. Like I said, folks, resonance is challenging. I will go through these and show you. We'll work a few examples here. So the first one. Okay, one of the things you want to do when you're drawing resonance structures, always put in your lone pairs. Okay? So you do have to remember, carbon likes 4 bonds, 0 lone pairs. Oxygen likes 2 bonds, 2 lone pairs. You see here, oxygen has 2 bonds and 2 lone pairs. That's why it does not have a formal charge, folks. Carbon has 4 bonds. 4 bonds to carbon, no formal charge. Okay? Look, oh my goodness, oxygen has 1 bond and 3 lone pairs. It needs a formal charge. How do you calculate the formal charge for oxygen? Or any atom for that matter? It's always going to be the group number on the periodic table, and we say minus dash minus dots. Okay, so what group number is oxygen? It's group number 6. How many dashes are there? Or you can say bonds. 1. How many dots are there? 1, 2, 3, 4, 5, 6. Okay, so here 6 minus 1 minus 6 is a negative 1. So you need to memorize that oxygen likes 2 bonds plus 2 lone pairs. If not, you need ding, 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 formal charge. Carbon, 4 bonds. If it has 3 bonds, it's going to get a positive charge. If it do not have 5 bonds, it can't break the octet. We do not break octet. This is second period, folks. Nitrogen, 3 bonds plus 1 lone pair. Okay? So anytime we have that bonding pattern. Now, hybridization. Oxygen here And if you don't know hybridization, you need to go back through and listen to my lecture. Okay, so do we count the lone pairs as a thing? Okay. Okay, well, sometimes we do and sometimes we don't. So you could say that's 4 things. And so 4 things is SP3. So we did S1P3 equals 4 things. That was kind of our shortcut to hybridization. Okay, but then if it can be in resonance, okay, so if the lone pair can participate in resonance, meaning if it's next door atom is an sp2, then it has to become an sp2. Resonance wins. It's like rock, paper, scissors, right? It's the rock. All right. So this means this oxygen is sp2. That was also a quiz question a lot of people missed. This carbon is sp2. This carbon is sp2. This carbon is sp2. And this oxygen is sp2. And we can look at carbon. It has 3 things. 1, 2, 3. And if you add the superscripts there, you see it's sp2. Okay, that's the first thing I do when I'm getting ready to do a resonance. I'm taking a look at the molecule and I'm looking for lone pairs. And I'm looking for pi bonds. Pi bonds are double bonds, folks. Okay, those are the electrons that can move. Now, what happens is pi bonds can become other pi bonds. Lone pairs can become pi bonds. And pi bonds can become lone pairs. And I try to just move either 2 electron flow arrows at a time or 1. Okay? If I'm pushing negative charges, then usually you need 2. 1 electron flow arrow is when I'm dealing with a positive charge cation. Okay? And that if I only do 2 electron flow arrows or 1, then I'm usually going to get every resonance structure that I need. Okay? I'm going to be looking for formal charges. I'm going to make sure that my atoms fit that. And I'm going to make sure I have these resonance arrows. Okay? So it's a double-headed arrow. I'm testing you. Do you know how to do double-headed arrows? We're learning how to communicate in structures. You're learning a new language. All right. So if I come up to an atom that's an sp3, so basically a carbon that's sp3, I'm not going to put any electrons there. Okay, so let's do this. We go here. There's 1. I can't stop there, folks, because that would give this carbon here 10 electrons. That carbon cannot have 10 electrons. So now I got to push those onto there. Okay, and then I redraw. All right. And then when I give that carbon 2 electrons, it gets a negative charge. All right. Now, move this so it's not so confusing. Okay. So what do we have here? I'll give it a look, okay? This overall molecule has an overall negative charge. Does my overall molecule have an overall negative charge? Yes. Okay. Does every atom have a complete octet or less? 8 electrons or less? Yes. Okay. So that's a good resonance structure. Is it a major or minor? It would be a minor. Why would this be a minor? Well, this is our major because the negative charge is on the more electronegative oxygen. Carbon not so happy because it's more electropositive. All right. Can we make another one? Well, are there some sp2 carbons? Yep, there is. So now I'm going to push those electrons onto that. So I'm going to go from a lone pair to a pi bond. And then I'm going to go from a pi bond to a lone pair. I have to push them off that carbon because that carbon cannot take 10 electrons. And then I redraw. Okay, so now I redraw this part of the molecule. I didn't do anything. I'm just going to redraw that. Okay, now we have that pi bond is formed. That one goes up here. All right. Overall negative, overall negative. This is also a major, folks. We have 2 majors. All right. So that is an example of where you just do 2 electron flow arrows. Let's do an example where you do just 1 electron flow arrow. So that example would be 11C. Now I'll draw the first one like this, but then I'm going to draw just the stick structures, well, line structures. Okay, we have a double bond there, we have a double bond there, and then we have a cation there. So let's look at that formal charge on carbon. Okay, we know that that has a formal charge because that carbon is only bonded to 3 bonds. Okay, so what's the group number? 4. How many dashes? 3. How many dots? What's 4 minus 3 minus 0? Positive 1. What is carbon like? I always say my happy atoms. 4 bonds. 0 lone pairs. That's what these have. 4 bonds. 1, 2, 3, 4. No charge. All right. Our overall molecule has a positive charge, so every structure better have a positive charge. Electron flow arrows are going to pull towards that carbon, okay, because that carbon has an empty p, unhybridized p orbital, in which it's pulling those electrons. Electrons are negative. They're attracted to positive. And then we redraw, okay? Now I'm just going to redraw, make a little pentane here. All right, and once you get good, you'll realize that you can, well, this might be confusing for you, so tell you what I'll do. I'll take the time to draw the carbons, okay, because it's important that you redraw exactly like you see it. Sometimes people just made silly errors. Silly errors are not counting your carbons. It matters. If you are working in a laboratory and you order something, you spend $1,000 on it, then and you ordered the wrong stuff, your boss is going to yell at you. Okay, so count carbons. It matters. Traded places. If you haven't learned this, you'll learn this in chapter 4, but this is a carbon bonded to 3 other carbons, so that would actually be your major. More stable structure. Okay, so examples 11B and 11C. 11B, you have 2 electrons, and then 2 electron flow arrows, and B, that's just to do 1 at a time. Let's do E example. I noticed not a lot of people got E. And then we can also do the quiz question open response for your resonance structure. Okay, so this is the problem given to you. Now, just because that is given to you doesn't mean that you just don't problem solve. You have to put in lone pairs. So I wanted you to see that if oxygen has a negative charge, it has 6 lone pairs. Or 6 electrons. This oxygen is neutral. When you're drawing resonance structures, it's the electrons that are moving. You need to put them in there. All right, so one of the structures, remember I said, let's just, you move 2 electrons, most electron flow arrows. Okay, I always find my negative charges. Where do I start? I start with my negative, and I'm going to push it towards a positive. I always look at my charges. Now, folks, I want you to see something. This carbon here, several people made this problem. That carbon, that is an sp3 carbon, folks. That is a carbon with 3 hydrogens. If you want to draw in your hydrogens, you can on these. So you can count. This carbon has 1, 2, 3, 4 bonds. Okay, add your superscripts. Okay, so that's not going to participate. The only atoms that are going to participate in resonance structures are these green ones. These are the only ones that we can push electrons on. Okay, now, so we want these electrons to go towards the positive. So we're going from a lone pair to a double bond, a pi bond. We're going to have to push them off the nitrogen, because if we leave it there, nitrogen gets 10 electrons. We cannot break octet. So we're going to push the electrons from the pi bond to lone pair. All right, so now we redraw. Did we do anything in this part of the molecule? No. Okay, so we just redraw that the same. Now, nitrogen gets a positive. Why does nitrogen have a positive? Well, what's the formal charge? Group number 5, minus dashes, minus dots. What's 5 minus 4? Plus 1. Okay, is this overall neutral? 1 plus and 1 minus? That's neutral. Is this overall neutral? Yes. Then we're doing the right thing, okay? We're doing good. Did I put my lone pairs in there? No. Okay, another one we can do now. We can move the pi bond to the nitrogen. You see how we can, and then we can move this here. And then we redraw. You took these electrons away, folks, from this carbon. That makes that carbon positive. Is that overall neutral? 2 positive, 2 negatives? This would be a major minor, wouldn't it? Major minor. That would be a minor. Definitely a minor. These would be majors, and they would be equally majors. Okay, this would be a minor because it has lots of different charges. Lots of charges. More charge, less stable. All right. I told you that we would work your problem for your quiz. So let me pull that up real quick. Okay, so this is the problem. All right, so here is the problem for our quiz that you were given. Okay, so let's count carbons. 1, 2, 3. That looks good. Okay, now what I want you to do is to recognize, okay, nitrogen, it's got, go ahead and draw that in. It's got a lone pair there. This oxygen has lone pair, and then this carbon has a lone pair because of the negative charge, okay? So you got to practice putting in your lone pairs before you do your resonance structures. This is a resonance arrow. Now, let's look at the atoms that can participate in resonance. They have to be the sp2. Also an sp could participate. You don't see it as often. This carbon is an sp2. Oxygen there would be an sp2, and this carbon's sp2. Which ones are not? This is an sp3, okay? So the sp3 are this and these, okay? We cannot push electrons there. Now, I always start with my negative charge or my positive charge. If I have a positive charge, I'm going to pull those electrons. If I have a negative charge, I'm going to push them. And so we're going to push it towards the other sp2 carbon. That carbon cannot hold 10 electrons, so then a pi bond becomes a lone pair. And then I redraw. All right. So what do we have here? These carbons here are still the sp3 carbons that did not participate. This carbon had a lone pair that became a pi bond. You see that there. And then these electrons didn't do anything. and then those electrons here, the pi bond became a lone pair, okay? Now, I also check, what's the charge, overall charge of my starting original compound? -1. What's this charge? -1. Okay, I'm happy with that. We conserve charge. Okay, do we still have an atom that has not gotten to participate yet? Because the oxygen has participated, the carbon, this one. This nitrogen has not yet. So now, for our next structure, we can have this nitrogen. Now, the problem is I'm going to have way too many electron flow arrows to draw another example. So what I choose to do is I just redraw the original. And I say, what if I started with the other side of the molecule? Okay, so I redraw this. Okay, so make it look like the original. We have that nitrogen, that carbon, oxygen. Okay, and this is your quiz. Now, what I could do is I could push these pi electrons, or these lone pairs, into a pi electron and then go like this and then redraw. Okay, so what does that look like? And, okay, those weren't touched. Now let's look at this. So if these became the pi bond here and the pi bond became the lone pair, is this correct? Nitrogen needs to have a positive charge. Okay, so the positive and the negative give me an overall negative. And so I check that to make sure that's fine. Now, would this be a major or minor? That would definitely be a minor, okay? Because we have lots more charge than we do in the other. And that was your quiz question on resonance structures. Okay, the last thing I want to cover is acid-base reaction. You will get an open response acid-base reaction, and I need you to be able to do it. Okay, so you have been studying about pKa values. I will also put another file, if I can find it, from another book that I found that has some excellent pKa values. These are the rules, okay? 1, you assign or you label acid, base, that's on the reactant side, and then conjugate acid, which I write CB, and conjugate base on the product side. Okay, step 2, you assign pKa values. Folks, what do you think the A stands for? Acid, to the acid on the reactant side, and the conjugate acid on the product side. We only want 2 numbers to compare. Some people decided to put pKa values on bases and conjugate bases. I don't know what to do with 4 numbers. I don't, okay? I know what to do with 2 numbers. And why do we need to compare the numbers? Because we got to draw in the equilibrium. Now, I know your book had those equilibrium values as equal, and that kind of annoyed me. The book annoyed me, but you're going to either have them, it's either going to be like this, and I write your assessments, so you got to get used to seeing what I like as part of the POGL experience, so you can get better on quizzes and exams. But see, this is equal, okay? So if we're comparing a 15 and a 16, you're going to choose something like that, okay? This is, okay, let's say a 20 and a 5, okay? That's like a 20 and 5. This might be a 20 and a 5 over here, okay? So this is your products and this is your reactants. Products, reactants, products, reactants, okay? And these numbers have to be assigned. What do those numbers mean? Well, if you subtract 20 from 5, that's 15. But remember, this is a log scale if you do pHs. So that means 15 zeros, okay? So I always tell my classes, if you don't think that's a big number, 15, put a $sign in front of it, okay? And then you see how big of a number it is. That means the equilibrium is either that far to the products, that far to the reactants, okay, or equal. And I like that people write forward and reverse, that's great, but I need you to also communicate with these equilibrium arrows, because I'm teaching you how to communicate without words. This is the universal language. I've worked with a lot of people around the whole entire world, and mathematics and structures, even if we have different words and letters and alphabets, this is the same, folks. Okay, so you're learning a new language. Now, let's work an example of what I expected. Okay, I'm going to work a couple examples, 2 of these, and I expect you to do the same thing every time. Okay, so let's look at, we'll do this one, B308. Now, maybe you don't realize it, but that's S2 sulfuric acid, Lewis structure. Now, I'm going to tell you, I would prefer you to draw the Lewis structure for each one of these. Because when I say I prefer it, I strongly suggest it with my power of grading pen, okay? So I don't even like it like that, okay? I want Lewis structures. This one here, which a lot of times you might not have time to do a complete Lewis structure, okay? But especially in the beginning, you really see what's going on. So there's your Lewis structure. Now what you have to decide is, where is your acidic proton? Where is it? Well, did you ever learn sulfuric acid? Your inorganic acids are going to be a lot more acidic than anything with carbon, okay? So that's why anytime I see these, I assign them a -10. Now, I don't know. Maybe it's a -5. Maybe it's a -3. We don't care. We're organic chemists. This is an inorganic acid, okay? You'll see me writing HBr, HI, HCl, -10. It's just the strongest. And this is the proton on that hydrogen that's getting taken away. And what does that become? That becomes H2SO4. I know you've seen that before. What does that look like? Okay. And yes, you could draw resonance structures for that. Okay. All right, so this is your product side. You have to be able to, draw those reactants. So now the electron flow arrows, you're going to want 2. You're going to want 2 electron flow arrows. And they always go from the lone pair to take away a hydrogen, the acidic proton. And then the covalent bond gives away its electrons. Okay, that's what you're saying right here. When you take these lone pairs and they go after that hydrogen, and then those electrons are going to oxygen. And that's where they are over here. Okay, that's that formal charge there of oxygen. And then we have to draw the products. So this is your products. All right, so this is, and now oxygen has a formal charge of plus, okay? So wherever this is your acid, folks, because that's your acidic proton, and over here is your conjugate acid. I really don't even care about your base and your conjugate base. Maybe I should just make people only label acid and conjugate acid. Okay, this one we need pKa value. I said -10 because it's a strong acid. Here, okay, this is not alcohol. So you might see charts with alcohol. That is a pKa between 16 and 18, okay? Branched ones, tert-butyl alcohol and stuff. This is where I say learn your functional groups and makes life a lot easier for you because you're learning a new language. But this is a protonated alcohol, so that's more acidic. And I think that's about a plus 1.7. Okay? So, now, step 3. You draw equilibrium arrows towards what? The highest number. Highest pKa value. And that's always going to be your weakest acid. Alright, so here you got a -10 of positive 1.7. If you don't know which ones that is right off the bat, put a dollar sign. You'll know. let's do this one here, this one here. You all know sodium hydroxide is base, okay? Whenever I see sodium or metals, I put a positive and negative because it tells my eyes where to go. This is one of the hydrogens we're going to take, and it's going to be this lone pair that comes here, and then it leaves those electrons, so I draw my product here now. There's my lone pair left, and then, you guys, this positive, it's an ionic bond. It's just floating around in solution. So it's going to be attracted over here. And then what is this? This is water, folks. Water. Water has a pKa of about 15.7. The pKa of this is called an sp3 carbon. Some books say 50, some say 60. I put 50. So you're looking at 50. Let's write acid on the reactant side. Let's write conjugate acid on the product side. 50 versus 16. There's your equilibrium arrow. Okay, what's the difference? 34 zeros. I'm not going to write all those out. I want you to understand that's a big number. See if you can do the F examples and G. I think that sums up our summary of what I expected you to be able to do this week. I know it was a lot. We're moving fast. Next week, we're into Chapter 3. And I'm looking at your POGIL activities. So just keep working at them. Oh, we're going to be drawing chairs and stuff. Much drawing and learning how to name alkanes. So keep working it. Send me some emails. I'll probably put another summary out. I'm thinking Wednesday because I'm thinking you're going to need a summary before Thursday. I know I have put Thursday as your POGIL activities, but I think it's in your best interest to even get them in by Tuesday if you can, okay? Because that gives me a 24-hour grading session on Tuesday to get those back to you, and so you'll have them for your Thursday exam. And then Wednesday evening, I'll post a summary video, what I'm seeing, and kind of help you. And right now I'm logging off, and I'm going to add your all's 5-point POGILs extra credit because I'm very proud of you for learning how to do all the technology and being brave enough to take this class, and I'm here for you. Bye-bye.